All right, today we're going to talk about section 9.3, which is talking about congruence in triangles, that means equal to, similarity in triangles, and we're going to be talking about the Pythagorean theorem. So congruent triangles are just triangles that have the same size, the same measure, and same equal angles and everything. Similar triangles are two triangles that are the same shape but different sizes. And Pythagorean theorem is used to find missing angles of right triangles. So congruent triangles. What I want you to pick up on this slide is a couple of things. First of all, the definition is that triangles that have the same size and shape are called congruent. The second thing that's very important is to note the notations that you see here. The angles are marked with arcs. Like angle E is marked with 3 arcs. And when you look at the other triangle, angle B is also marked with 3 arcs. So that denotes that those two angles are the same measure. Angle D is marked with 1 mark, and angle A is marked with 1 mark. So that denotes that those two angles have the same measure. And then angle F and angle C are each marked with 2 marks, so that denotes that those are the same measure. The other thing to note is that angle or side DE, notice we have that hash mark there instead of the arc, and side AB each have 1 mark. So that tells you that those two sides have the same measure. And the same thing with DF and AC. So down at the bottom, what you'll note here, and this is extremely important, this is saying that triangle ABC is congruent to triangle DEF. And so just being given that notation tells you all the corresponding pieces that are the same. A is the first letter, so it has to match up with D. So notice A and D have the same mark. B is the second letter, and E is the second letter, so they have to be the same values. And that continues on through that. So there are actually 3 different properties, I think it's 3, that we're going to talk about of ways to prove that 2 triangles are congruent. And the first one is called SAS. And SAS stands for side, angle, side. And I've given you a picture down here that shows what side, angle, side would look like. The angle that is congruent must be between or included between the 2 sides that are marked. So for example, if I gave you a picture that looks something like this, and I had this side marked and this side marked and this angle up here at the top marked. That angle that is marked is not included between these 2 sides. It is opposite one of the sides, so it is not, this would not be a side angle side problem. The second option is what we call angle side angle, ASA. So it's angle, side, angle, side, angle. So in this case, the side is included between the 2 angles. And you can remember that by the wording. The S is between the 2 A's. The third one is SSS, which stands for side, side, side. And that just tells you that 3 sides of one triangle are equal to 3 sides of another triangle, then the 2 triangles are congruent. So what we're going to look at are some proofs, because that's the easiest way to understand how this is applied. So the first thing you have to see here is what is given to you. You are given this information. Now notice there are no angle marks in this. So that's telling that CE is a side and ED is a side. So CE is equal to ED. And notice I'm putting the marks on the pictures if the pictures aren't already marked. The second thing says that AE is equal to EB. AE is equal to EB. Now we know, given this picture, we have two lines that are intersecting, and whenever two lines intersect, they form vertical angles. So these two angles in the center here are vertical. So I have two sides marked in this triangle. I have two sides marked in the other triangle. I have one angle marked in each triangle. So I'm going to write my proof. This is what we call a two-column proof. And the first two statements I wrote are just the information that they gave me. And that's my reason for writing it down, is that it's given. The second thing, or the third thing I wrote is this green angle that I marked here. And so you've got to pay attention. This angle in this triangle is CEA. So here we have angle CEA and DEB, so DEB, and those are congruent or equal because vertical angles are equal. And so now I'm able to prove what I want to prove, that those two triangles are congruent because of side, angle, side. So here's another example. Now notice on these givens, you'll see the notation for an angle. So I've got to mark angles in my pictures, not sides. ADB, here's the easiest way I can tell you to trace it. Start your pencil at A, go to D, and then go to B. And you'll notice that this is the angle that they're talking about. So angle ADB and angle CBD is this angle. So those two angles are equal to each other. ABD and CDB are these other two angles that are marked. ABD and CBD. Now this next property that I'm going to give you here is a new property, and it's called reflexive. And reflexive property means you basically have the same thing on both sides. So what I need you to note here is that you've actually got two triangles in this picture. Here's triangle ABD. And your other triangle is CBD. And you'll notice that both of these triangles have this side BD, but they're stuck together. And so it's what we call a reflection or a reflexive property. So DB equals DB, step 3, is one of those properties like the vertical angles that you can always state. It's called reflexive. And so we're going to state that those two sides are congruent because of reflexive property. And again, the reason that we want to do that is because we need to get sides and angles in the picture so that we can use one of those three methods that we learned. And that's what we've done here. If you look at the picture, you've got these two angles, and you've got the side in the middle, so you've got two angles and one side. So you've got two angles and one side, which is angle, side, angle. Sorry, let me go back one. Now this is an example, another example of where you see the reflexive property. Again, notice that you've got this side coming down the middle that is shared in both triangles. So that side is congruent, and again, here we have the reflexive property. So anytime you have a picture that has two shared sides, that's what we call a shared side, then you're going to note that one of your choices is going to be reflexive property. Anytime you have a picture that has vertical angles, remember vertical angles, look for that X with the intersecting lines, vertical angles are these. Anytime you have vertical angles, you're looking at that as being one of your choices. So again, on this property, on this proof, we mark that AD and CD are equal, so that's these two marks down here. And we mark that AB and CB are equal, that's these two marks here, and those were given to us in our proof. And so now we have three sides marked in each triangle, so the triangles are congruent because of side, side, side. All right, so there's some important information you need to keep in mind about isosceles triangles. And one of the things you have to note about isosceles triangles is that if these sides are the congruent sides, AB and BC are equal, then that means that this angle and this angle, they're called base angles. Base angles are congruent to each other. So think about the sides across from those angles are equal to each other. This angle at the top is called a vertex angle. If I were to draw D, and D is the midpoint, then I know that if I draw this line right down the middle here, BD, I would know if that's the midpoint that this angle up here is equal to this angle up here. And I would also know that these two angles are right angles if D is the midpoint. Okay, so when we have similar triangles are triangles that have the same size and shape, the same shape but different sizes. So one of the triangles is going to be bigger or smaller than the other one. So with similar triangles, the angles have to have the same measures. So the angles are going to be congruent to each other, but the sides are going to be in a ratio that is constant. So the corresponding sides are proportional to each other. So anytime you talk about things being proportional, you can set up equations and cross multiply. So the one property that we deal with similar triangles is the angle-angle similarity property, and that's what allows you to prove that two triangles are in fact similar. Now you'll notice that there was not an angle-angle congruence property, only similarity. So with congruent, I had to have a side in between. I had angle, side, angle. So here we have a problem, and we're saying that triangle ABC is similar to triangle DEF, and we want you to find the length of DF. So when you look at this, DF corresponds to AC. And if you're not quite sure if that's true or not, look at the position of the letters. DF are the first and last letters, and A and C are the first and last letters. So we're going to call DF X, because that's the one we're trying to find. So we're going to say X over 32, because those two sides should be in proportion. And then we're going to set up the other one as the other two sides that we know, 8 and 16. So equals 8 over 16. And now we're going to solve this problem by cross multiplying. And so when we cross multiply, we're going to get 16x. Sorry, let me get this back up here. Okay, we're going to get 16x equals 256. And then we're going to divide both sides by 16. So x equals 16. And so x is df, so df is equal to 16. Now sometimes you can look at the problems and just figure out what the ratio is. How did you get from 8 to 16? You multiplied by 2. So how am I going to get from, or if you want to think of it this way, you divided 16 by 2 to get backwards. So if I divide 32 by 2 also, I would end up with 16 back here. Now that only works if you multiply or divide by something. It will not work to add or subtract. All right, so here we have another thing, another problem, and this time I want you to find the lengths of xy and st, and I want you to find all the missing angles. So let's start with the angles. They're telling you that TSU is similar to XYZ. So that means angle T and angle X have to have the same value. So if angle X is 71, then angle T has to be 71 also. Angle S and angle Z have to be the same thing. So since S is 52, Z is 52. And now what we want to do is find y, or u, and to do that, I know that the angles of a triangle have to equal 180. So I'm going to add up 71 plus 52. I'm going to get 123. And then I'm going to subtract that from 180. And I'm going to get 57. So angle u and angle y have to equal, that should be an and symbol. Not very good symbol. Let me just do it this way. Angle y and angle u have to equal 57 degrees. Now to find the sides, it's a little bit more work. I'm going to start with, it doesn't really matter which one you start with, but I'm going to start with this angle, this side down here. So I'm going to say x over 40 equals 144 over 48. And this is the ratio that I'm going to use, or the proportion that I'm going to use to solve for the value of x. So if we cross multiply and solve that problem, I have my answers down here. We're going to end up with 120, xy equals 120. So x is equal to 120. So let me set up my problem again so you can see it better. Okay, so to figure that out, again, we're going to take x over 40 equals 144 over 48. We're going to cross multiply, so 48x equals 5,760. So x should be 120 degrees, or 120. And then to find ST, we'll call ST y. We're going to do y over 126 equals, again, I'm going to go back to the 48 and the 144 because those are my constants that I know. And we're going to cross multiply again. Oh, I forgot to do that. 146 times 48. So that equals 6048, and then divide by 144, so x equals 42. All right, so here's another case, and in this case you'll have to notice that there are two similar triangles here. All right, so we have this small similar triangle that I have in green. And in that similar triangle that's in green, I'm going to draw a copy of it here. I have this side is 15 and this side is 9. Okay? And then I have a big triangle, and the big triangle goes from here all the way down, and it goes all the way across. So the big similar triangle has a value of x right here, and this is something you have to watch out for. The value of this bottom piece is 25. So when I set up my proportion for this problem, I'm going to set it up as x over 9 equals 25 over 15. So again, cross multiplying, you get 15x equals 225, so x is equal to 15. All right, so here's another example. A house is 15 feet tall. Its shadow is 40 feet long. At the same time of the day, there's a shadow of another building that's 300 feet. How tall is the building? So here you have the house. Okay. And the house is 15 feet tall. And the shadow that the house projects is 40 feet. And then over on this other side of the town, you have this building that's much taller. And you don't know how tall the building is, but you know that the shadow that the building is projecting is 300 feet. So this is just a similar triangle problem, because what you're going to do is set up your ratio, 15 over x equals 40 over 300. And then you can cross multiply, so 40x equals 4,500. And then divide both sides by divide both sides by 40, and so we find out that the building is 112.5 feet tall. All right, the next topic we're going to talk about is something called Pythagorean theorem. And Pythagorean theorem is a theorem that was created many, many years ago to find the missing leg of a right triangle, or the missing piece of a right triangle. And in Pythagorean theorem, there are three pieces. There's A and B. A and B are always the legs of the triangle. And there is C, and C is always the hypotenuse. And the hypotenuse is always across from the 90-degree angle. Okay, the hypotenuse is always the longest side too. Now some people feel like they can look at it and say the hypotenuse is always the slanted side too. And that will work a lot of times, but you have to be careful about how it's oriented when you set that up. So in this problem, you do not know A, you know B is 36, and you know C is 39. Again, here's your 90-degree angle, it's assumed, and it's across from the 90-degree angle. So we're going to set up our Pythagorean theorem. So A squared we don't know. B squared is 36 squared. C squared is 39 squared. And if we continue to do the math, we're going to subtract 1,296 from both sides. So we get A squared equals 225. Whenever you have a square problem and you're trying to solve it, to do the opposite of squaring, you take the square root of both sides. So the square root of 225 is 15. So the missing side of the triangle is 15. And make sure that this makes sense. If you look at the picture, 39 is supposed to be the biggest side of the triangle. This one's 36 and this one's 15, we just found out. So that does make sense that we have found the right value. All right, so let's look at another one. This time we're looking for C. This is the C value because it's across from the 90-degree angle. It's the hypotenuse. So this is going to be A and this is going to be B. So we set up our problem. 8 squared plus 15 squared equals x squared. 8 squared is 64. 15 squared is 225. Combine those together, you get 289. And then the square root of both sides will end up with x equals 17. So the missing side of the triangle is 17. Again, it does make sense. It is the longest side of the triangle, and it did come out to be the biggest value, so that does make sense that we did it right. Now, sometimes we have something called the converse of the Pythagorean theorem, and that is, what if I give you three lengths of a triangle, and I say, do these three lengths form a right triangle? So, for example, if I gave you the numbers 3, 4, and 5, and I said, if I put these three lengths together, will I get a right triangle? Well, we know that C has to be the biggest one, so that one has to be C. The A and B don't matter. It doesn't matter which one's A and which one's B, so you can just go in order by the ones that are given to you. So 3 squared plus 4 squared. And we want to know, does it equal, that's the question mark, does it equal 5 squared? So we're going to do the math. 3 squared is 9, 4 squared is 16, 5 squared is 25. I just put that in my calculator. 9 plus 16 is 25. This side is 25. So since they are equal, the answer is yes, it is a right triangle. If these two values were not exactly the same value, then you would say no, it does not form a right triangle. So let's look at another example. I have 4, 7, and 8. Again, 8 has to be C since it's the biggest value. So we're going to do 4 squared plus 7 squared. And we want to know, does it equal 8 squared? So 4 squared is 16, 7 squared is 49, 8 squared is 64. 49 plus 16 is 65, and this is 64. So they do not equal each other. So these two triangles, or this triangle, is not a right triangle. This is not a right triangle. All right, I hope this is helping. Keep in touch with me. I hope you're having a great week.